Hello again. Welcome to Module 7. This is Aggregations in Materialized Views. Now, we talked about Materialized Views in Module 6, but I avoided aggregations. There is something very unique that you have to do if you want to keep track of an aggregation in a Materialized View. In fact, there's a special table engine just for that called Aggregating Merge Tree, and there's some very specific data types that have to be used in an Aggregating Merge Tree table, and those data types, these aggregate function data types, have very unique functions that you use to sort of get those results. Like let's say you want to keep track of a running average or a running count or something like that. Those have to be done in a very specific way, and that's the focus of this chapter. For what it's worth, we're in chapter 7 of what is really 12 individual courses leading our way through the ClickHouse developer learning path. All right, let's get started. Let's look at how aggregations work in materialized views. And there's actually a special table engine for that. We saw the merge tree table engine, and we had mentioned before that it's a family of table engines. So this will be our first time using a different table engine than just merge tree. It's called aggregating merge tree, and it's designed specifically for, well, it doesn't have to be materialized views, but typically for materialized views, but it's designed specifically for aggregations inside a view like that. And I'll show you sort of the motivation behind this. In the example we saw in the previous lesson, we talked about views and materialized views, and I totally avoided an aggregation inside the view. But that's a super common thing to do. Suppose I want to run this query over and over again, or I want to find the average price of homes in the UK price paid data set by district. I have, millions of rows, but suppose I was doing that over billions of rows. Yeah, it's fast, but it's repetitive. I have a bunch of historical data. I have all the data from yesterday all the way back to wherever my data is stored. Okay, I can compute the average of that, but I don't have that much new data coming in relative to all the old data. So why add up all those numbers again to compute the average of billions and billions of rows? What I really want to do is keep a running average. When new data comes in, I want to update the average. Well, I want to show you how that works because there's a little bit of effort to that. To compute the average of a bunch of numbers, it's not as trivial as knowing what the previous average is. I need to know how many numbers there are, and I need to know what they add up to so that I can divide them. And so like I said, that's a little bit of effort. There's a table engine for that. It's called Aggregating Merge Tree. And I want to sort of show you some motivation for where this is coming from. I'm going to do something that is really sort of wrong, completely wrong. I'm going to create a table, and I already have it all typed up here, so it'll go pretty quick here. I have a table called Sum Numbers, and it's got two columns, an ID and a value. And the primary key is the ID. I'm going to create an aggregation. This is going to be my materialized view destination table. And I want to keep track of the maximum value for each ID. And I want to keep track of the average of all the rows that have the same ID. Well, okay, don't try this at home, but I'll just create a table and then I'll create a view. You'd be very tempted to do this. The syntax is valid. ClickHouse lets you do this. ClickHouse lets you select the maximum value and the average value grouped by ID. And I'm going to put that, like I said, up here in this lovely table, ag of some numbers. Let's try it. Now I don't have any data anywhere, but I like the idea of keeping track of the maximum value for each ID and the average for each ID. So let's put some numbers in. So I'll put in 4 rows, and two of the rows have a 1, so a 10 and a 20. The other 2 rows have an ID of 2, 300 and 400. And you can see all 4 rows are inside my table. And if you look at the destination table, it looks right. This is 20, for example, is the maximum value of all the rows where ID is 1. 15 is the average of all the values where ID is 1. 350 is the average of these 2 rows, and you can see the maximum is 400. Okay, it worked once, but now look what happens when I insert a couple more rows. And I'm going to sort of add extremes. So I'm going to make a row or add a row where the ID of 1 is 1,000 and the value of X for ID 2 is 20. So now I have 6 rows in my destination table. My aggregation table, my destination table, okay, it took the results from this insert right here. The maximum value for 1 was 1,000, and the average, well, I don't even know where it got. Oh yeah, 1,000. Well, 1,000 is what the average of this one row is. And then it took the 2 group by 2, and it found the maximum value of that is 20, and then the average is 20. Well, that totally messed up the numbers now. Like, this is not the average of any of the values. I don't have a way to get the proper average. I suppose I could try to be clever and select the maximum ID. You know, I need to group it. I could try and, I don't know how to get the average though. The average is a mess. Like, this is really where I lost it. If I do ag of some numbers, and I group by ID, I get back a maximum value of 400. That's right. If I go up here, that was the maximum value of all the rows where ID was 2. But the average is not 185. The average of 300 and 420 is not 185. What is it? 300, 400, it's 720 divided by 3. It should be 240. So the average is wrong. Where the group by ID is 1, the maximum is 1,000 if you look at all the rows where the ID is 1, but the average is not right. The average of 10 and 20 and 1,000, well, that's 1,030 divided by 3 should be 343.3, and the average is 500. This is not a running average. So I got lucky with max, and I didn't get lucky at all with average. This just isn't the way to do it. And so I'm going to go back, and now that we have this sort of, reason to not just do it this simple way, I'm going to show you what's going to seem like a complicated way, but it is how you do aggregations in Materialized Views and ClickHouse. There's 2 column types you have to know about. Really, one aggregate function. There is a simple aggregate function, and I can show you the difference in the docs. If I look at simple aggregate function, these are the lucky ones. If I'm going to continue that storyline, it's any, last, min, max, and sum, and these other ones here with maps and bits. Okay, so there's a dozen aggregate functions where you don't have to do a lot of work to keep a running minimum, a running maximum, a running sum. But for the rest of the ones, there's a little bit of effort involved. If I want to keep track of an aggregate function, I need to use this data type. Notice I'm in the data type section in the docs. This is a data type. Both of those are. And so let's take a look at how it works. This is the example in the slide. So feel free to kind of go through this. I just drew nice little pictures and went through the example and kind of showed where the average got lost. What I want to do is look at the UK price paid example. Well, here's the one that I just did. Well, here's what I should have done. I should have used simple aggregate function with max for the max column, and I should have used aggregate function with average for the average column. And then when you put the columns in, you have to use these special functions, max, simple state, and average state. You have to use the state combinator functions that go with these data types right here. So simple aggregate function, you pass in 2 values. The function that you want to aggregate on, which is max, and then uint32, that's the data type of the values coming in. For aggregate function, same thing. Average, AVG, that's the function I want to take the aggregate, the running average of, or that's my aggregate function. And then uint32, that's the data type of the values coming in. Notice my engine is aggregating merge tree, not just merge tree. And the primary key is, in this case, is the ID column. So this will be my destination table of my materialized view. Now, when you create the materialized view, you still use the to clause, send it to the destination table, but my query has to be a little bit different. You don't just pick the maximum value of the incoming rows. You don't just take the average of the incoming rows. They're the wrong data type, by the way. The average or maximum are just numbers, but I need them to be simple aggregate functions and aggregate functions. Take any aggregate function, you can append state to it. So average is my aggregate function. Average state saves the values of all the intermediate information that it needs and returns an aggregate function. Simple state, you can't put that on every aggregate function, but you can put simple state on the simple state aggregate functions, which were max and min and sum and those few other ones. And those return simple aggregate functions. I went back a slide again. So now everything lines up. It's important to group by ID because up here on the previous slide, my primary key was ID. That absolutely has to match. And now when I insert rows into this sum numbers that I called it, instead of just grabbing the maximum and the average, it grabs everything it needs to keep a running maximum and a running average. And that's the difference. So now, well, here you can see I got the right answers this time. When I added the 1,000 and the 200 this time, the maximum was always right, but now the average is correct. That's what it should look like. I'm going to sort of go through. Oh, by the way, I'll show you this in just a little bit. When you do look at those values inside the destination table, you'll see binary data. You have to, if you want to view those values, you have to view the merged data. Let me show you an example. Let me actually run the code. Let me go over here and I'm just going to copy and paste. I'm going to start over again. I'm going to drop the table, some numbers, and then create it again. I'm going to drop that aggregation table that I have, and I'm going to do it right this time. I'm going to use aggregating merge tree, and the data types are going to be aggregate functions or simple aggregate functions. And then I'm going to drop that view that I had. I'm going to redefine the view using the corresponding state functions that go with my destination table. And now when I insert some rows, they're there. I mean, now I have 4 rows here, and if I look at the 4 rows, that all looks fine, except of course the average column is a little bit odd. Let me show you something. What you really need to do is, instead of selecting the column itself, which is called max underscore column, you should pick the maximum max underscore column, first of all, because you might have multiple rows. And then second of all, you need to merge it. Well, with max, it's a simple function. I don't have to do that. But with average, I do. So there's a little extra step here. I need to take the average merge of the average column. And you'll see here in just a second what that difference is. This is ag of some numbers, group by ID. Let me put the ID up here because I want to see what it is. And now you can see that I actually get a number back instead of that weird sort of binary data. Let's insert some new rows. Let's add a couple new rows. This is where we went wrong in the previous example. I'm going to go back up and run the same query again. There's the 400, that's right. There's the 1,000, that's right. And notice here I get the averages. They're correct. Again, if you don't call merge, which is fine, I just want to show it to you, you just get binary data back. Ag of some numbers. There you go. All right. So it's a 3-step process of creating the destination table using aggregating merge tree, using state functions to populate that table, and using merge functions to view the final result. And so these 3 components involved make up the whole process, the whole steps through it. All right, let me go through another example. We've seen the UK property prices data. What I want to do is get the average price, the maximum price, and the 90th percentile of all of the data by district, so per district in the UK property prices data. So I'm going to put this up here for a second, and we'll kind of start right here. So this is going to be my destination table. It's an aggregating merge tree. So all my data types either have to be in the primary key or they have to be aggregate functions of some kind. I'm going to compute the average. I'm going to compute the maximum. And I'm going to compute the 90th percentile. I don't know why that says float. Those are UN32s coming in. I'll change that to UN32. So I'm going to create my destination table. Oh, I think I already did. Let me replace it. Okay. And then I'm going to create my view. This is my destination table. So I'm going to send it to there. It's from UK price paid. I'm grouping by district because I have to. That's my primary key here. The sort order primary key thing has to match the group by here. And I'm using the state functions. And now I get to use simple state for the maximum function because that's a simple aggregate function, but the other 2 have to use state. I'm going to keep a running average and a running 90th percentile. Okay. So, and right now it's empty. Why is it empty? Well, because it didn't populate it. So my materialized view is lovely. It's ready to go, but I don't have any data in it. So I'm going to have to go back and historically populate the table. And this will take a few seconds. I mean, well, that was faster than I thought. But that's because it's just doing an average and a max and a 90th percentile. And ClickHouse does those things very quickly. Look at the result. It's interesting. And the results come back by district. So every district has an average price, a max price, and a 90th percentile. The maximum price is readable. I can see the maximum price of Aberconway. But the average is It looks like a couple of binary numbers. And the 90th percentile looks like a whole list of binary numbers or binary data. It's not even readable at all. Well, that's because if you want to read these values, you have to call the corresponding merge function. I don't have to call merge for max because that's already there, but I do need to merge the results in those other two columns. And now I get back now I get back the average in. Well, the district's resorted, whatever MEN-DIP is, the average is 206,659 pounds. There's the max, there's the 90th percentile. Nice. And that sort of puts it all together, that whole three-step process of using aggregating merge tree, using state functions to populate it, and merge functions, the aggregate combinators, to retrieve the results. All right, I can talk about this all day, and it won't make any sense. You're going to have to figure this out on your own. And so please go through the labs. I have another merge tree that I didn't show you called summing merge tree, which is a step easier than aggregating merge tree. Summing merge tree has a default behavior of adding columns together. So it's kind of nice. It's easy. If that's the only aggregation you want is to add a bunch of columns together, you can use summing merge tree. And the numeric columns will get added together in the materialized view. By the way, summing merge tree is a child of aggregating merge tree. You can use summing merge tree and sneak in a couple of other aggregate functions as well. But in the lab, you're just going to keep the running total of all the prices by town. And then in the second lab, you're going to do a running aggregation on the UK property prices data set. Again, you have to do this. You almost have to sit down and type these things, go to the docs, check out the aggregate functions, the simple aggregate functions. If you go to aggregate function combinators, you'll see that in the docs as well. We've been to this page before in a previous lesson, but you'll notice that simple state and merge are all mentioned here as well. And so be sure to check that out if you have any questions or more details about it. And like I said, please work through the labs. If you get stuck, have any questions, don't forget to go to our Slack channel, our community Slack at clickhouse.com/Slack. Look for the ClickHouse Academy channel. Send an email to learn@clickhouse.com. We'll be happy to help you. All right, good luck.